All right, class, this is the video for section 3.2. We're talking about two major rules, the product and then the quotient rule. There are more we were talking about, so the next rules are these two. The following are our learning objectives for this section. At the end, you should be able to understand and apply the product rule to solve problems or to find the derivative of functions. And then the quotient also rule to do the same thing, depending on whether the function given is a product or is a quotient. Okay. Now, let's talk about the product rule. Now, if you have the sum, right, the sum of two functions, we differentiate, we say that, and then the difference, right, that we talked about in 3.1. For the sum, you just differentiate both of them, and either you add the results or you, you find a difference. Now, when it comes to product rule, it's not analogous with the sum or the difference rule. In other words, if you are given two functions of multiplying, you don't find the product, the derivative of each of them, and then find their product. Okay, as you can see in this example, suppose you have f of x as what, x, and then g of x is what, s squared. Now the product rule gives that if you differentiate f of x, you get 1. If you differentiate the g of x, you get 2x. Okay, so let us also find the product of the two, that is x times x squared. That's what we have for s cubed. Then if you are finding the product, if you find the derivative of these two functions, right, that is if you write f of g, okay, this means that you are yet to find the derivative with respect to x, and that gives me the derivative of x cubed is what, 3x squared. Now, as you can see, if I multiply, okay, f prime of x, okay, and I multiply by g prime of x, that's 1 times 2 of x, which is what, 2x. Now, these are not the same, okay? The right hand side is what, 2x, and this is what, 3x squared. Of course, these are not equal. Okay, so there must be a way to find the product rule or the product of our two functions when you want to find the derivative. Okay, now here is the rule. Okay, if you have two functions, g of x and f of x, which are differentiable, okay, what this rule states is that, okay, keep the first function multiplied by the derivative of the second function. So your first function is, this is the first, and this is what, the second. So you keep the f of x and multiply by the derivative of the g of x plus, okay, and then keep the what, the second function, and this time multiply by the derivative of what, the second function. So in other words, in the Leibniz notation, if u and v are functions of what, x, and they are differentiable, then what it says that keep the u and multiply by the derivative of the second, that is the v, plus this time keep the second and multiply by derivative of what, of u. Okay. In other words, the product rule says that the derivative of a product of two functions is the first function times the derivative of the second function plus the second function times the derivative of the first function. So we want to apply this to some examples. Okay, the first one we'll look at is exercise number 3, which is giving us what? 3x squared minus 5x in parentheses, that is one function, and then e of x. Okay, we know how to differentiate e of x, and then if you're a polynomial function. So in this case, this is the first function, and that is what, second fourth function. Now, the rule says that, remember, if you have u and v, and then if you find it with respect to x, it says what? Keep the u, multiply by the derivative of the v, plus keep the v, and multiply by the derivative of the second function. And so here, what that we do is that we keep the first function, which is 3x squared minus 5x, we keep that, we don't do anything. Then multiply by e of x, we got the derivative of that, plus we keep the e of x, and then we multiply by the derivative of the what? The first function, x squared minus 5x, and then we differentiate that. So let us differentiate. If we differentiate e of x, we get what? E of x. Okay, and then we have 3x squared minus 5x times that. Then e of x, then when you differentiate the, what is the parenthesis? To differentiate 3x squared, you get what? 6x. To differentiate 5x, you get what? You get 5. Okay, so this gives me the what? The first derivative. Okay, but we can simplify this. Okay, now if I look at this, e of x is a common factor, so I can pull that out. Then I have what? 3x squared minus 5x plus 6x minus what? 5. So this is simplified into e of x, 3x squared, and then plus what? X minus what? Minus 5. So now this becomes, this is my what? F prime of what? X. Okay, f of prime of x is what? Is that. Okay, now if you want to find the second derivative of that, okay, so f prime of x is what? The derivative of what? The f prime of x. So let's differentiate f of x, f prime of x again. Okay, which means that using the product rule again. Now this time my first one, the way I've written, I can bring the e of x to the side, and that's the same thing. So let me keep it as it is. So I keep the first what? Function, in this case that's my e of x, then multiply by the derivative of the second function, which is 3x squared plus x minus 5. So I'm going to write it. So when I put it there, I'm yet to what? I've not differentiated it yet. So I'm just writing it out, then we'll differentiate in the next step. Plus, now you keep the second function, okay, which is what? 3x squared plus x minus 5 times the derivative of what? The second what? The first function. Okay, so this is equal to, we have for e of x, and then when you differentiate this guy here, you have for 6x, okay, plus what? Plus 1. Then plus, we keep what? We have 3x squared plus x minus 5. Now, if you differentiate what? E of x, you get the same what? E of x. Okay, so again, if we pull out we factor out the e of x, then we are left with what? 6x plus 1, then plus 3x squared plus x minus what? Minus 5. Okay, so let's simplify what is in the parentheses. That gives us what? 3x squared and 6x plus x is what? Plus 7x minus what? Minus 4. Okay, so this is my what? F prime of x. That is what? That is that. Okay, excellent. All right, so let's go to the next example. Okay, this will require some algebra. So we're going to take I'm going to do it in 2 ways. Okay, the second way will be very simple, but I will do that last so that, okay. Now, this is very simple. If you have a function like this, all that I can do is that first I can what? Multiply this out and then I differentiate it. But I'm going to differentiate using the product rule and then multiply it out and then differentiate, just to show you. Okay, so here h prime of x, u, okay, keep the first one, which is what? U minus square root of u. And then we multiply by u plus what? Square root of u. And we differentiate that. Okay. So we keep that. And then this time we keep the second function, which is u plus what? Square root of u. And then we multiply by what? U minus square root of U prime. Okay, so this is equal to what? U minus square root of U. Okay, if you differentiate this guy U with respect to U, not X, but with respect to U, that would just be 1. That would be just 1 for the U. And then if you have U, square root of U is what? U raised to what? 1/2. Okay. So if you have that, if you differentiate that, you have what? You differentiate this guy, okay? If you differentiate U raised to 1/2, you get 1/2, okay? And then U raised to 1/2 minus 1. And that gives you 1/2 U raised to a minus 1/2. So it will simplify into 1/2 times square root of U, okay? So if I differentiate plus U, square root of U, I get what? If as I've done over here, I will get what? 1/2 square root of what? Square root of U. Okay. Then plus, this time we get what? U plus square root of U. And then we multiply by 1. And then that gives me minus, similar to, if you have this is minus, everything will be minus minus. Okay. So that will also give me 1/2 square root of what? Square root of U. All right. So now this is equal to, let's multiply this out. Okay. Let's FOIL that. U times 1 is U. And then U times 1/2 root U. Okay. We get plus U/2 square root of U. And then minus U times 1 is minus square root of U. Minus U times that will be square root of U over 2 root U. Okay, they will cancel out. So by we'll write in the next step. Then U times 1 is 1U. And then U times minus 1/2 square root of U will be U over 2 square root of U. And then you have plus U, square root of U times 1 will be plus square root of U. And that will be minus square root of U over 2 square root of 4U. Okay, so now look at something here. Positive, negative square root of U will cross out, we'll cancel that out. And then we have what? Minus U divided by 2 square root of U. And then we have plus U divided by 2 square root of U. That also will cancel out. Now, square root of U will cancel that, and that'll give me negative 1/2. Okay, and over here, square root of U will cancel square root of U, gives me negative 1/2. So that will result into what? U plus another U, then minus 1/2 minus 1/2. So that is equal to what? 2U minus 1. Okay. All right. On the other hand, okay, on the other hand, if I have my H of U, okay, which is that? U minus square root of U, and then U plus square root of U. Now look at it. This is what? Difference of squares. Okay. That's difference of squares. So if you multiply this out, you have what? U squared minus square root of U times square root of U, which is just what? Let me write it, square root of U times square root of U. And that gives me U squared minus U. So now my H of U is equal to what? U squared minus U. So then let's differentiate that. So 8 prime of what? U. Differentiate U squared, you have what? 2 times U raised to 2 minus 1, then minus 1. See that? Few steps you are there. But you don't usually get simple things like that. Okay, that's why I wanted to use the product rule. So using the product rule, this part here, we use the product rule. Okay. And then over here, we just simplify and then use the what we learned in section 3.1. The power rule of differentiating polynomials. All right. So the next powerful rule in differentiation or in calculus is what we call the quotient rule. That is when you are given rational functions and you want to differentiate them. Okay. Now, this rule is very important, and that is, if you have two functions, one is dividing the other, f divided by what, g, and of course, the g of x is not equal to 0, okay? The g of x is not equal to 0, because if it is equal to 0, then it is undefined, okay? Now, if these two functions, f and g, are differentiable, okay, if they're differentiable, so that means that to differentiate this is the rule. It says that you keep it's g of x, keep the bottom one, multiply it by what? The derivative of the function f, minus, please note that, minus f of x, okay, the top one, keep that and multiply it by the derivative of the bottom one. Then divide everything by the square of the what? The denominator. So keep the denominator, okay? So denominator times the f prime, that is the derivative of the numerator, minus numerator times the derivative of the denominator, all divided by what? The square of what? The denominator. Okay, now I'm going to show you another way to recall this rule. This is what my high school teacher taught me, probably in the 90s, okay, maybe 1989 or 1981. And then he said that, okay, let us call the f, which is the numerator, let's call it the top function, okay? Let's call it the top, and then denominator, let's call it what? The bottom. All right, and then this operator, let's call it what? D, D-E-E, all right? Then this rule is stated as this. That's a way to remember. It says what? Bottom times D top minus top times D bottom, all divided by bottom square. Okay, bottom times D top, that is the derivative of the top function, minus top times derivative of the bottom, all divided by bottom squared, or you can say all divided by the square of the what? The bottom. Okay, so we're going to apply this, and before that, let us summarize all the rules that we have learned so far in this chapter. That is 3.1 and 3.2. Okay, remember the constant function. If we differentiate a constant, you get 0. This is the power rule. That is the derivative of what? The exponential function, that's e of x. You get the same e of x. That's a derivative of the function times a constant. So bring the constant out, because the constant doesn't depend on the variable, say f, also x. Okay, so bring that. And then the sum, the difference, and this is the product, and that is what the quotient rule. Okay, so g times f prime minus f times g prime divided by what? The bottom square. So d, bottom d top minus top d bottom, all over what? Bottom square. Okay, now let's apply this to this. Now, I want you to know that this function over here, y, it can also be written as x is equal to minus what? X. Okay, now then when I write this one, then I can use what we call the what? The product function, the product rule. Okay, but, okay, there's a big but here. Now, if we want to differentiate, we haven't talked about how to differentiate e raised to negative x or e raised to say 2x or something. To do this, we need, okay, you need what? The chain rule, okay, which we have not talked about. In fact, we'll talk about in the next section, 3.3. Okay, so we are not going to write this as that. However, I want to mention that when we finish 3.3, we can do the same thing, writing as a product and using the product rule and the chain rule for that. But we're going to use the quotient rule in this case. Okay, so the quotient rule of that, so you have y prime is the same as what, say, keep the bottom. So e squared, so e to the x times, we have the top is what? You differentiate that, minus, you keep the top, and then you multiply by the derivative of the bottom. all divided by what? The bottom or square. Now, let's see that this is e to the x. What is the derivative of x? This is 1 minus, you keep the x. The derivative of e to the x is the same what? E to the x divided by, if you have e to the x all squared, so that some of you can see that this is e times e to the x times e to the x. And that gives me what? E to the what? X plus x, which is what? 2x. Okay, so then the denominator is just what? 2x. Okay. Then let's look at it. Have e to the x, 1 times that is e to the x minus x e to the x. Then of course, we can simplify this, which is numerator factor e to the x, and then you have 1 minus what? X divided by e to the what? 2x. Now, don't you see that this will cancel one of those? Okay, this will cancel one of those. So that is be what? 1 minus x over what? E to the x as your example. Sorry, the final answer. Okay, so that's the derivative of what? Using the quotient rule, which is basically if you have what? The derivative of what? The f over what? G. It says what? G f prime minus f g prime all over what? G squared. Okay. Now, let us go to the next example. All right. We're going to apply the quotient rule. Now, as you can see, once you apply the rule, the rest is what? Algebra. So I cannot emphasize enough. Okay. I cannot emphasize that enough. Your algebra must be stronger. You must review it and do as more. Otherwise, as we go, especially when we get to the chain rule, it will be, I promise you, okay, it won't be easy if your algebra is not strong, okay? All right, now let's do another example, okay? Now the bottom, this is my G, this is my what? This is, sorry, that's my F. Now remember the quotient rule states what? It is what? Keep the top, the bottom, differentiate, multiply by the derivative of the top minus what? Okay, sorry, it's the other way. F times G prime over what? G squared. Okay, so my G of x, G prime of x, I mean, is equal to, we keep the bottom one, which is what? 3 minus 4x. Okay, then we multiply by the top, the derivative of the top, which is 1 plus 2x. Okay, we are going to differentiate that. Then minus, then I keep the top 1 plus 2x, then multiply by 3 minus 4x, the derivative of that, then everything divided by 3 minus 4x, that's the bottom square. So bottom the top minus top the bottom all over what? Bottom square. Now let us differentiate that and then simplify. Well, we have our 3 minus 4x intact, we don't touch that. Then differentiate the constant, 1 is 0, differentiate 2x, we get what? 2. Minus, so you keep 1 plus 2x. Then if you differentiate 3 minus 4x, differentiate 3, you get 0, and my negative 4x, you get what? Minus 4. Then divided by 3 minus what? 4x, all what? Squared. So now let's simplify. Okay, simplify. You have multiply this out. You have going over 3 times 2 is what? 6 minus 8x, the numerator. The minus negative 4 times minus 1 is what? Plus 4. And then you have what? Plus what? 8x. Okay, because negative times you get minus 8x, then there's a negative outside, and that will make it positive. Okay, divided by 3 minus 4x all squared. So the numerator basically gives us what? That will cancel out, will be what? 10 divided by 3 minus 4x all squared. Okay, so that's a good one to see. And then we're going to have maybe one more example. Okay, now this example, exercise number 23, It's you have to use a combination of what? The both product and then the quotient rule. Why? Well, as it's written, it is what? A function divided by another. So that's what we talk about. We use the quotient rule. But look at the numerator. Numerator is what? X squared times what? E to the x. So that requires what? The product rule. That's why I said you have to use both what? Both rules that we have talked about in this section. So let's differentiate. My f prime is equal to this. You apply the quotient first. Okay, quotient first. Quotient rule. Now keep the bottom, which is x squared plus what? E to the x. Then we differentiate what? The numerator, which is x squared e to the x. When I write it this way, it means I'm yet to find what? The derivative. Then minus, I keep the top, x squared times e to the x, then differentiate the bottom, x squared plus what? E to the x, and the derivative of that, and then x squared plus e to the x all squared. Okay, so now let's differentiate those ones with the parameter, sorry, the prime or the operator. That gives us x squared, okay, plus e to the x. All right, now if I differentiate this, that's why I use the product rule. Okay, I use the product rule. That's keep x squared multiplied by what? The derivative of what? E to the x, plus I keep the what? E to the x, then multiply by the derivative of what? X squared, like that. Okay, then minus, I keep x squared, e to the x, then I have what? X squared plus what? E. Sorry, this gives me 2x. Sorry, that gives you the differentiate you have for just 2x. If you differentiate e to the x, you get the same thing, e to the x. Then everything divided by what? X squared plus e to the x all squared. Okay, so then what we have there is that we have x squared numerator plus e to the x. All right, then we have x squared times e to the x, then plus e to the x. If you differentiate x squared, you get what? You get 2x. Okay, then have minus x squared e to the x times 2x plus e to the x. Okay, then everything divided by what? X squared plus e to the x all squared. Okay, so we're going to multiply this out. Let's go to the next step here. Let's multiply this out. These are 2. So x squared times x squared e to the x will give me x to the 4 e to the x. Then x squared, I'm following that, x squared times this, the second time there will be plus, we have 2x there, so that'll be 2x cubed e to the x. Then e to the x times that will be x squared e to the x times e to the x. That will be e to the what? 2x. And then e to the x times that other one, the second term there will be 2x times what? 2 e to the what? 2x. Then minus, okay, 2x times x squared will make me 2x cubed e to the x. Then minus again x squared e to the what? 2x. Now everything there divided by x squared plus e to the x all squared. Some of the terms will cancel out in the numerator. As you can see, this will cancel that because that's minus, that's positive. And I have 2x e to the 2x, okay? And then I have x squared e to the 2x. This is negative, this is plus, so that will cancel out. So all we have there is this, okay? Everything is going to be equal to, okay? We are left with what? X to the 4 e to the what? X, then plus 2x e to the what? 2x. all divided by 3, so x squared plus e to the x all squared. Okay, now as we can see, we can factor something out in the numerator. X is common, and then also e to the x. So we have x times e to the x outside. They have for x cubed for the first term there. I've got x cubed, then plus 2, then times what e to the x, then divided by x squared plus e to the x all squared. So this is my answer, the derivative of what? Of that function. So again, note that in this function here, we apply both what? The product rule and the what? The quotient rule. This is where I apply the product rule. Okay. Okay. That brings us to the end of this section, and I'll see you in the next section, the video for the next section. Thank you, and see you soon.